So, as you mentioned, I'm Chris Jackson, a PhD candidate at the University of Colorado Boulder. I'm very excited to talk about meta-analysis and the social sciences, a bit of theory and a bit of practice from my own experience working with it on a project with some co-authors at the university. Briefly, an outline for my talk. I'm going to start with a quick anecdote, sort of how I got into being an advocate or practitioner for meta-analysis. From here, I'm then going to move on to defining what it is, why to use it, some broad appeals to it or utility of meta-analysis. I'm then going to specifically focus on meta-analysis for early career scholars, specifically those maybe with a dissertation on the horizon. After this, it'll set up a nice discussion for the key steps in a meta-analysis, um, as well as looking at meta regression analysis. That's what MRA is, specifically publication bias. And I'll end the talk with a couple of really, really excellent resources that help me get started. They're really excellent guides, like an introductory type guide, even if you don't know anything about meta-analysis. All right. Feel free to jump in with questions or anything. I don't think, see anybody, but ask away if you have a question. All right, oops. So a quick anecdote. After my first year of grad school, I was working with Dr. Shannon in our university on some papers on peacekeeping, and I had read what seemed to be hundreds of articles and was either coming to the conclusion that I am bad at reading, or it doesn't seem as if the field has like one definitive, concrete conclusion about, peacekeeping 100% of the time reduces conflict onset, for example. And while there is some existing work that tries to address these in our subsequent work, we saw that most of it is either just a singular study with the aim of trying to, distinguish between some competing hypotheses, or just a very large review of the literature, like a review paper. And to us, this wasn't necessarily satisfying, especially since what we were trying to do is look for one way to systematically characterize the entire current scholarship on peacekeeping. And so one way to go about doing this is with meta-analysis. That's where that systematic component comes in. And so what actually is a meta-analysis? Well, we can define it as a statistical technique that systematically synthesizes the entire body of research on a particular research question. Statistical technique and systematic are important here, especially as we're maybe distinguishing on either more qualitative ways of doing this, like a lit review or a narrative review. And it also helps in visualization for what the actual literature looks like. Like I said, if you're reading through hundreds and hundreds of papers in working on your dissertation or research papers, whatever it is you're working on, you might want to visualize what it is you're actually finding. You can even dig deeper into, is there publication bias or things like that. And this is primarily used to just synthesize evidence, like I said, maybe reduce or even acknowledge that there is publication bias in a literature. And of course, to increase statistical power compared to those individual studies that I mentioned in the anecdote. Rather than just increasing the number of observations, you're actually able to include study model observations to look at this kind of at a more meta level. The benefits of this is that since the goal is to produce a single best estimate of the relationship between a key independent and a key dependent variable, you're able to sort of distill a large body of work into a couple of key statistics, that pooled estimate of where the literature stands, as well as some dispersion and heterogeneity, if that's necessary. And second, we can think of research sort of conceptualized as a series of forking paths, quite literally at every stage of the research process. Maybe after you've decided what your research question is, how are you going about defining concepts? How are you going about measuring those concepts? What are the research design strategies that you're using and implementing? And so all of this can lead to heterogeneous findings. And that's where meta regression analysis in particular can help to kind of sift through moderators, look at certain things that might be leading to these heterogeneous findings. Is it a different type of estimator or measurement strategy, whatever that might be? And then particularly for early career scholars, it's really helpful to collect and code all of these articles because one, it helps you to, again, visualize what the field that you're working on looks like. And two, you can use that data set in the future, at the very least, just as a data set, to refresh your memory on what the literature looks like. Or if you're working through the dissertation, you can search for specific key terms, maybe what's the most cited of the papers that you're looking at, for example. So what's unique about meta-analysis? Why not maybe just stick with a more common narrative review? The narrative review, the goal there is to synthesize research in a more descriptive way and to highlight themes, trends, or theoretical implications. So you might be picking out one or two important things. The critique here sometimes is that there is either a little bit of qualification or hedging going on in some of the claims that you're making, or two, you could be critiqued for perhaps omitting some important studies from that narrative or lit review. The meta-analysis then adds some statistical rigor by, again, systematically quantifying these relationships. And since you're able to produce that one single best estimate, my advice is, if possible, try to use both. This way, scholars can try to present a stronger case for why their research is needed, in addition to sifting through all the literature and identifying, here are some of the weaknesses, here are some shortcomings that you have identified just by reading. You can also statistically demonstrate, there's publication bias, or maybe people are focusing too heavily on this one type of estimation strategy as opposed to another. And that's what's driving heterogeneous results in the field. So why use meta-analysis? We can think of this there are at least 6 different ways or reasons. Half of those, the first 3, are more statistical, and the other 3 are on the substantive side of things. So first, like I said, it quantifies effect sizes. Usually this is done with a partial correlation coefficient. That's the one I'll be talking about later today, but there's also Cohen's d, odds ratios. There are a couple different ones. I focus on partial correlation coefficient, and that is the general advice in the field because it's really easy to use. You only need two pieces of information from the studies that you're coding, and it's usually done quite simply just in R data with a line or two of code. So very simple to do. But this
Chris?
one, yes.
Oh, I just wanted to let you know that your slides are not progressing.
Oh, no. Thank you so much for letting me know. Okay, let me try sharing again. Okay, do you see this now?
Yes,
Is it moving?
it is.
Awesome. Okay. Sorry about that. Thanks for letting me know. All right. So quantifies effect sizes, the partial correlation coefficient. And so this is helpful in visualization, for example, and for those maybe stubborn committee members on the dissertation committee, or maybe reviewers in the journal reviewers who are maybe not convinced by your contribution or the value added of your work. You're able to quantify maybe the gaps in the literature. Second, it improves statistical power because you have not just more observations, but sort of a meta approach to this. You're able to at least theoretically improve the precision of the results and should also get more reliable effect sizes. This is especially if you cast a wide net, which is sort of the advice in the field to do this. Be more inclusive rather than exclusive with the articles that you're including. And finally, for the statistical benefits, it reduces bias. At the very least, it helps you account for or address whether there is publication bias in the field. But best case scenario, you're also able to use a method called trim and fill to account for that through imputation. So you're able to account for publication bias and also resolve that. On the more substantive side of things, and I think this is where it gets more interesting, is that it can resolve inconsistencies in the field. And I think Lee, Owen, and Mitchell in political science, at least in international relations, is probably my favorite example. They're looking at how regime type affects or draws towards you foreign direct investment. They're arguing that it could be things like uncertainty that other regime types have that makes FDI less likely, or it could just be property rights. And so they're able to parse through these inconsistencies or discrepancies in the literature and try to provide a new, more formalized research agenda or program moving forward. Second, on substantive side, I can detect different moderators. So things like sample size, methodology, demographics, really quite anything, any type of study characteristic that you think could be driving heterogeneity in the field, you're able to parse through these and identify statistically which are the things that are leading to these changes. And finally, we can identify research gaps in new directions. I think my favorite example here is Godefroy 2022, who's looking at how terrorism affects sociopolitical behavior. And she comes to the partial conclusion that that research or that literature had been biased by focusing primarily on Islamic terrorism and then Western responses to that type of terrorism. So the conclusion there is that more research should be focused on non-Islamic terrorism and maybe non-Western audiences. Some example topics in the social sciences, these are just sort of after a cursory look through the different social sciences. I hope maybe up to this point, you're already starting to think about your own literatures or the spaces in which you work, if there is maybe those inconsistencies there where meta-analysis could be useful. A couple of topics in IR, the effective international sanctions on regime stability, the effect of peacekeeping on conflict outcomes like duration, civilian protection, onset of civil conflicts or conflict in general. This is the project that I'm working on with co-authors at my university. The association between social trust and civic engagement, the effectiveness of anti-bullying programs in schools, the impact of universal basic income on labor market participation, the effectiveness of online versus in-person learning, the effectiveness of anti-smoking campaigns on smoking rates, or the impact of prison education programs on post-release employment. These seem to be areas, of course, I'm not an expert in the non-political science ones, that could be great for meta-analysis, especially if there are those inconsistencies or mixed findings, for example. Okay, and before I start talking about the specific utility for graduate students, I wanted to do a quick pivot to kind of show the state of meta-analysis in political science and what's kind of motivated me to, like I said, be a practitioner and an advocate for this tool. First, it seems that it has grown in political science and really the social sciences generally. The mentions in the top journals like APSR, AJPS have increased a good bit over the past couple of years, but it doesn't seem to be commensurate with what graduate students are doing. For example, in 2020, we looked through every single one of the dissertation in political science, and only one of them actually used meta-analysis substantively as like an empirical chapter. So one full chapter focusing on a meta-analysis. And so despite the high utility for a couple of reasons, maybe a lack of familiarity or perceived complexity, maybe methodological training gaps, these are probably the reasons why graduate students are doing it less. For example, I know that in my method sequence at University of Colorado, there isn't a class or a class dedicated solely to meta-analysis, and there's also not a class that really focuses on meta-analysis during like 1 or 2 of the weeks. So either you're not exposed to it as a graduate student, or you simply, once you have been exposed, don't know how to go about conducting it. So I'm hoping then that maybe this next section will be an appeal to and sort of like your first exposure to the utility, and then also to maybe how easy it can be to do a meta-analysis. There are 4 general benefits for, I think, specifically graduate students on why meta-analysis is good for them. The first is about the fact that you are producing a very comprehensive data set, a comprehensive and exhaustive data set of all of the articles that you're reading. And like I said, this is similar to the lit review, but you have the added benefit of not necessarily needing to hedge or qualify statements. You can point to the data that you're using, being transparent about your inclusion and exclusion of the articles, and then you produce that single estimate that can really substantiate the claims that you're making in the narrative or literature review. And since you're using that single summary, again, you're able to visually show this and empirically demonstrate what you think the gaps in the literature are, where you think things should be moving forward. And so, like I said, if this is used as a complement to a narrative or lit review, then you have a nice, comprehensive, and exhaustive collection of the literature on a topic that you can also revisit. The second benefit is that there's the potential to expand the researcher's professional network. Maybe less important for more established faculty and scholars, but for someone like me, a grad student close to the job market, it's very helpful to be able to expand that network. Going to conferences is, of course, one way. But if you reach out to other researchers who you know work on this topic or a similar topic to see the type of work that they're doing, that's a really great way to make connections. At the very least, you have a new paper for your meta-analysis, maybe best case scenario, it's a foot in the door for some research with someone else, or maybe job opportunities, etc. This is something that we did, by the way. One of my colleagues sent out emails to all the people in the field of political science working on peacekeeping in the hopes that they have working papers or something like that that we can include. What the literature has done, for example, is to seek out conference papers from, I think it was the American Political Science Association. Costa then sought to use email listservs to contact colleagues, and then someone that I interviewed went so far as to go on and request papers on Twitter, send out emails on listservs, and then they contacted up to 100 people who they knew were working on the topic. Again, this is a big benefit for graduate students to broaden your network or your professional network, can help with co-authorship or maybe job opportunities. The third benefit is, again, specifically for those working on their dissertations. This could serve as its own chapter. So, you can nicely check off one of the 5 or 6 or however many you're working on. The one out of 178 that I looked at in 2020 used it as an actual empirical chapter, though I think it could also work very nicely as maybe not a standalone chapter, but something that complements the theory or lit review chapter, again, to provide a little more empirical support for the claims that you're making. And it really helps set the stage for important questions that committee members or reviewers at journals might have, such as, one, what do we already know? And I think the lit review does a good job with this. And more important, I think, what are open questions in the literature that we don't know? And so by answering these questions with a meta-analysis, you're able to justify your contribution as well as bolstering the lit review. The final benefit is that the dataset can be used in the future as a searchable database. Imagine that you, again, have looked through hundreds of papers, you've coded them, now you're starting to write. Maybe you're at the conclusion and you're wanting to say, what was that one certain operationalization of the dependent variable? I know in comparative politics, for example, it's the difference between democracy being measured at a 0-1 dichotomous scale versus a -10 to 10 more continuous scale. So you might want to look at who is doing that or how many. Maybe you're saying that most people are doing it wrong because they're focusing on the wrong operationalization. You can find the exact number of articles focused on that. You can also focus on, or if you're looking at the most cited article, maybe you're saying this is the most cited article despite using the wrong operationalization. Maybe looking at a certain type of estimation strategy, like an IV approach. Of course, this isn't an exhaustive list. Anything that you are forgetting, you're able to very quickly recall with that data set. People that we talked to have even said that they plan to use their data set, like Godefroy or a couple other people we interviewed, well beyond just that one publication or for their dissertation. In fact, they are planning to include more measures and studies for future projects. So at the very least, you can maybe think of this like comprehensive exams where you're studying a lot, you have all of this knowledge in your head, and then after comps, you maybe don't know it as well. Well, now you don't have to forget all of that stuff. It is right there in your data set. Although there are some benefits, there are, of course, some challenges. So let's briefly talk about those. First is the comparability issue. It is really important to be conceptually clear about which measures should and shouldn't be included during collection. This is easily one of the most important steps, which we'll talk about in the next section, being very clear about why you are including one paper and not another, and how that very specifically relates back to your research question. You want to also, though, make sure that you're not including just that single best estimate in your output, but measures of dispersion or heterogeneity to sort of contextualize the results. This depends on the type of model or estimator in meta-analysis that you're using, but you want to provide more rather than too little. And then finally, for the dissertation, this can be used to sort of defend the value added. Arguably, if you're writing a dissertation, then it's on a topic that is maybe doesn't have a whole lot of literature that directly talks about the specific things that you're talking about, but surely there's like tangentially related material that can be used to, demonstrate the hole in the literature or the gap in the literature where you're looking to fill that. The second issue is issues with inclusion, and this is where the garbage in, garbage out critique comes in. How good can we say that that single summary result is if you're including papers that aren't very high quality? The solution to this is to include a weight on study quality. This can be, or usually is done with the number of citations or the number of observations in the statistical model, but that's not the only way to do this. And this again is where meta-regression analysis can come in to try to filter out, okay, are we seeing heterogeneity due to study quality, or are these poor studies not as garbagey as some people may critique them to be? Another reason to do this, to include lower quality studies, is because reviewers might not necessarily like an overly exclusive list. If your if your meta-analysis only has like 50 papers out of a possible of like 500, then why have you excluded so many? So the best practice here is to cast a wide net. The one exception to that is, or the two really, is if you can't reliably verify the results, say that you're having a trouble calculating that partial correlation coefficient and you're unable to do that, maybe you reach out to the authors and they can't provide you with the data or they don't respond, then at that point it's good to exclude it. Or of course, if there just aren't any quantitative findings, if it's just case study or like archival research, then there's unfortunately nothing to include there. And finally, is author-specific challenges. This is kind of the thing I was talking about when I was talking about meta-analysis in political science. Although this is time intensive, and especially for graduate students, writing a dissertation requires you to look through the entire literature anyway, and so you may as well spend a couple extra minutes coding the work that you're doing. And the other challenges are, like I said earlier, some people just might not be exposed to this type of stuff, either in a methods class or even knowing what this is. So the solution could be to collaborate with colleagues, as I am doing, not on my dissertation, but on a paper, using systematic review softwares, or best case scenario, try to hire one or two RAs with moderate methods knowledge is pretty important because you're needing to make distinctions during the coding of articles on, is this an OLS estimator? Is it a negative binomial or whatever else? And so that, moderate methods knowledge is necessary for the research assistants to be useful. Okay, now we're going to move on to the key steps in a meta-analysis. Now that we know what it is, some of the utility, especially for graduate students, and the first step is a collection and gathering of the data. So first, and maybe obviously, you need to make sure that you have a precise research question to investigate a specific relationship between one independent variable and a dependent variable. This is the case for really any research that you're doing. Through this, you want to identify key search terms for database queries. I am not going to talk about how to do this because I think it's a little beyond the scope of this talk, but using things like JSTOR, ProQuest, EBSCO, those are the places to type in these keywords, maybe the IV or the DV. What is important in this section is defining clearly the inclusion and exclusion criteria. This can be something like study design, publication type. I'll show what we are planning on doing for our meta-analysis on peacekeeping in the next slide. But what's really, really critical here is that this is done at the outset. You don't really want to fall in the trap of like post hoc theorizing where you have found 1,000 or so articles, you're starting to look through them, and then as you're looking through them, you're then deciding what to include and what to exclude based on what you're looking at. You want to make sure that you have very, very clearly thought this through. Ideally, it relates back to your research questions and the IVs and DVs that you're looking at. And very importantly, this should not be changed. And you should be very transparent about what these inclusion and exclusion criteria are, either in your paper or like in the supplemental information or appendix, something like that. For example, in political science, Kurtzer 2022 includes only experiments with randomized treatments fielded on both political elites and mass publics. I think the keyword here is experiments with randomized treatments. Then if it is maybe a more observational study or not maybe an experiment, then it's excluded for Kurtzer. That's a decision that he made on his study. And then best practices is try again to cast as wide a net as possible. Consider including things like unpublished studies or working papers, like the conference papers I mentioned earlier that one author group was looking for, as well as non-English or papers that are not in your native language. The goal here is to try to reduce bias. And if you're wary about including unpublished work in a meta-analysis, again, you can just code something that we are doing as well. Is this a published paper in a peer-reviewed journal? Is this maybe just a master's thesis? Is this a working paper, a conference paper, and so on? This is an example of what we are looking at for our inclusion exclusion. We are going by constructs, units, study, designs, and statistics. For inclusion criteria, for example, for statistics, we want to make sure that we have sufficient information to calculate effect sizes and precision. So to do that for the partial correlation coefficient, all you need is a t-statistic and the degrees of freedom. I'll discuss that at length in a moment. And then maybe what we're excluding on designs, for example, is meta-analysis already. That wouldn't really fit here. Case studies, news reports, editorials, things along those lines. It can be a little daunting, like I said, maybe 1,000 or several hundred studies. That's a lot to go through, especially if the plan is to be coding these articles. But fear not, you're going to be sifting through them and ultimately excluding quite a bit. This is just one example of starting with, looks like high 700s papers. You can already check off a couple because there are going to be some duplicates. There are going to be some that are like newspapers, for example, that just don't fit the scope of this type of project. And so while you might begin with 700 or 800 papers, you finish then with only 319 in this stylized example. In an example from the literature, Godefroy 2022 again starts with a whopping, looks like 10,000 studies, and then is able to narrow this down all the way down to 241. And these are the types of things that if you're doing a meta-analysis, again, it is considered best practice to do this type of Prisma flowchart or something that shows the specific process. You started with this large chunk of literature and now you've slimmed it down to just the most relevant based off of your inclusion and exclusion criteria. The next thing to do is to actually code the data. And this is where it gets really helpful to have more than one person doing it. It takes a long time. If you have like a research assistant or other colleagues helping you, you do want to make sure that you're doing some sort of intercoder reliability. What we did for that is randomly choose 10% of the articles, code them independently, and then see how things matched up and how we needed to revise our coding strategy. What you're doing though is creating a data set of study model observations. So each row in your data set is a study model. That means that you can have multiple studies be multiple rows because sometimes studies will have multiple models. I'll show this visually in the next slide, but the essential things to include in this data set when you're coding the articles that you have collected is the effect size, the standard error, the degrees of freedom. These key statistics, as well as, of course, like some identifying information about the journal or the article, author, and date usually suffices there. Additional variables, and this list knows no bound. Publication year, the data type, is it maybe cross-sectional or time series or panel data? The estimator used, these are literally just 3, but the data set for us has 76 total things that we're coding from the articles that we've collected. You don't necessarily need to fill each of those columns for each paper. Sometimes there's not going to be something to fill out, but it's better again here to cast a wide net, to spend a few extra minutes talking about an article or coding it to get more data in case you want to revisit it in the future. Dukuliagos and colleagues, for example, coded for continents and estimator types. We, instead of continents, did region. And then for our peacekeeping paper, for the peacekeeping variables, we're looking at the types of personnel of peacekeepers, troops, police, observers, civil affairs officers, and so on. This is then what it looks like. This is just an example data set. You see 3 different papers, Smith 2000, Jones 2001, and Percival 2010. And as I mentioned, each row then is a study model observation. So this is model 1, and the key the T statistic, that key critical information is 2.1, and then the degrees of freedom are 11. What you then do is for each one of these rows, create an individual partial correlation coefficient, and that's then summed together. That's what we're about to talk about. So how do we actually go about doing this? The effect sizes need to be standardized across studies. If you're even using the same type of estimator, you're going to have different measures that are ultimately telling you slightly different things. Even if it's conceptually still clear, it's still about peacekeeping, they can be measured in different ways. And so you want to make sure that this is standardized. The common approach is the partial correlation coefficient, or PCC, which binds the effect size between -1 and 1. Now, why the PCC? There are a couple of reasons. One, interpretive. It's a lot easier to look at a -1, that nice binding, and be able to say, okay, all of our 241 or whatever Godefroy had studies come out to 0.76. That very clearly shows us direction and magnitude. The next is, where'd my slides go? Contextual relevance. This is being able to see how much variation in the dependent variable has occurred due to the IVs. The next is consistency across studies. This is where the standardization comes in, so you're actually able to compare across studies. And then finally, it handles confounding variables by calculating the residuals for each, like for each PCC that you're calculating for each study model observation. It's able to produce the residuals for that to be able to account for other confounders. There are other ways of conversion. I believe I'm going to skip that in the interest of time. It's called a transform PCC that you would do if you have lots of different types of estimators, say it's OLS, logit, negative binomial, things like that. You would need to do an extra step, but it is still quite easy to do in both R or Stata or whatever you're using. So to do the PCC, it's very simple. Like I said, you only need two pieces of information. That's really the big appeal for it. Here's the formula. It's just the squared t statistic for study I model J over the t statistic squared plus the degrees of freedom for that study model, and then the square root of that. Notice since you have a square root, if the coefficients in your table are negative, then you need to adjust it accordingly. Once you have these individual partial correlation coefficients, you simply sum them together, and then that's what the P sub ij is, and the N sub ij is a weight. And that weight could be based on sample size, citations, study quality, inverse variance, journal impact factor. Again, this is a list that is kind of more context dependent on the research that you're doing. This is the transform PCC. Like I said, I'm going to move past this. But suffice it to say, there is a way to account for different estimators in the same analysis. And this is what a table for this outcome usually looks like. Unlike maybe in more regular regression output, the top part is a little heavier, where you have key independent variable followed by several controls and a constant. Here we're just producing a singular pooled estimate. In this toy example, it's 0.21. Recall it's bounded by -1 and 1 with a confidence interval of 0.14, 0.28. Here are the usual observations and model fit statistics, and then the I squared, H squared, and tau squared and Q are about heterogeneity. So I squared is the percentage of total variation due to heterogeneity. H squared is the ratio of total to sampling variability. Q is a chi-square test for heterogeneity, and then tau squared is the between study or the random effects variance. I'm going to move past this screen for time, but I'm happy to revisit these model statistics if you are interested later on. And finally, now we need to consider effect size models. So there are different types of estimators. There's a common effect model, which is used more in like those perfect gold standard lab settings with nearly identical randomized control trials or RCTs. This assumes a single true effect size. The fixed effects model then assumes different effect sizes, and I can actually visually show this. The random effects then is a distribution of effect sizes. So the fixed effects model, maybe think of like, how does a reading intervention program affect reading comprehension across all public schools in Canada? That would then be a fixed effects model. When you start seeing a lot of heterogeneity within the study, an example would be maybe looking at how air pollution and respiratory diseases across multiple countries interact. That's when you're starting to look at the random effects model. Now, how do you choose which one to use? This is quite important because it definitely affects the results that you get. The common effect model is used if there's no heterogeneity in effect sizes. Like I said, mostly for those gold standard RCTs. Fixed effect model, then, if studies are highly similar, for example, you're estimating a single best effect for included studies, and then the random effects model if studies differ in design, population, intervention, measurement, other ways where you're trying to generalize findings to a broader population to distinguish that with a common effect, then the population are just the people in those very identical studies. The bottom line here, though, is if in doubt, use a random effects model. There are two reasons for this, or statistical ones. He provides more conservative and generalizable results, and since it can account for study heterogeneity, researchers tend to prefer it for that reason, especially in the social sciences, just because, at least for us in political science, we don't have a lot of that perfect gold standard lab setting type experiments. We do survey experiments, but that's not necessarily quite the same thing. And so the lack of these gold standard experiments really pushes us towards the random effects model. This is a visual representation of what a very small subset of literally just two of the papers included in our meta-analysis look like. As you notice, these model stats are a little wonky because it's only 10 different observations from two studies. But what's nice about this forest plot is this section over here, where again, you're able to visualize specifically how the estimates from one study model compare to other papers, and then how that factors into the overall score at the bottom of 0.74. Perhaps a nicer way of showing this is through a cumulative forest plot is literally the same thing over here, except we are now doing this by chronology of publication date. There are countless ways to do this. You can go by estimate size. You can go smallest to largest, or maybe negative to positive, whatever you might have in your data. That way you can show how each subsequent paper or publication over time in this sequential one changes the overall score. This is the initial point. It's moved back quite a bit by the second and third and so on. It slowly steadies out with a Dersman-Smith paper. Since we usually have about 100 or so articles, maybe a little bit more, it just depends on the field that you're working with. This is the nicest way to illustrate this. It's called a caterpillar plot. This is all the hundreds of studies that have been fit into this meta-analysis to produce that ultimate measure. Godefroy has a really nice interactive version of her data online on a Shiny app where you can see something similar to this, mess around with different articles that are included, and then see how that leads to different outcomes. All right. So after those key steps and what you're actually producing with the meta-analysis, let's now move on to publication bias through meta-regression analysis. So publication bias occurs if the estimates are reported and manuscripts usually published based just off statistical significance of the effects alone. Also known as file drawer bias, could lead to a whole host of issues in the literature, also maybe incentivizes people to p-hack. And so the nice thing about meta-analysis is that since you have so much data that you yourself have coded about these papers, you're able to actually calculate the extent to which publication bias may actually exist in your body of literature. The easiest way to do this is the funnel asymmetry test, or FAT. The intuition behind this is twofold. For smaller studies with a larger standard error or lower precision, same thing, those should appear on the left-hand side of the plot, and then inversely for the large N studies with smaller standard errors. Now, you have bias if, kind of like the name funnel asymmetry test, if there's a non-funnel shape, especially for those low precision studies. The solution for bias is to do a trim and fill method, which can adjust for missing studies. That is through imputation, for example, where the studies that are missing on one side are literally just imputed to the other side. What do the sides look like? And these funnels, these are 4 examples ultimately showing the same thing, just with slightly different measures for precision. The x-axis is always log odds ratio, excuse me, and then the y-axis is the standard error or the variance or the inverse of those. As you can see from this first top left figure, it doesn't necessarily look super funnely. There are a couple of dots here that through that trim and fill method would likely end up over here to produce a more balanced funnel shape. Okay, so where do you actually get started now that you have all this information if you're interested in doing meta-analysis? Well, there are some really excellent readings that I can recommend. First off is Lipsey and Wilson, 2001. They have a book called Practical Meta-Analysis, which is a great way to, maybe after you've read an intro book, to actually get into doing and practicing meta-analysis. The second is by Stanley and Doucouliagos, 2012, called Meta-Regression Analysis in Economics and Business. It's this book. This is one of 2 of how I got into the field. Cannot recommend it highly enough. I think I do an excellent job. Don't be turned off by the economics and business section. I, as a political scientist, had a great time reading it and was able to learn a lot. Then Borenstein et al. These are authors from the biostatistics community, which is where meta-analysis originated. Very, very helpful tool, very, very comprehensive, a long book, but worth the read. You can also just focus on the relevant sections for you. Slow and Tyson, this is an article, not a book, on external validity and meta-analysis. This is where the term conceptual clarity comes in again, making sure that you're including articles that actually make sense for the research question and the relationship and aren't like super unrelated. And then on software, I used for this presentation Wolfgang Wichtbauer's package called Metaphor in R. It's even linked with the Bornstein et al. Book, so you can read the Bornstein et al. Book and then go to R with that data in hand, and plug it in to make some of those things like the forest plot or the caterpillar plot. And then Stata, their 17th edition at least, had some canned commands such as meta summarize. You can do the same things like funnel plots, etc. I am a proponent of R, so that's my favorite. Then comprehensive meta-analysis, I'm not getting paid for these endorsements. This is not a free resource, but it is a software dedicated entirely to meta-analysis. And then Revman, also not free, but you do get a free 1 month trial online to work on meta-analysis, maybe to get your feet wet, see how it works for you. And with that, I thank you for your time. Thank you for being here, and I'm happy to open it up to questions.
Thank you so much, Chris. All right, it looks like we have one in the chat. Do you have any priority advice or favorite resources for best defining inclusion and exclusion criteria?
That is again where I'd say like these books really come in and are super helpful. They're kind of the guide for us as to the things that you need to be considering. Like I said, that's where the suggestion of including non-English papers or unpublished papers came from, those two books in particular.
I'm curious to hear, you started with recognizing that within the literature that you were looking at around peacekeeping, there seemed to be real divergence. And I'm curious how you would describe the clarity that has come out of the meta analysis process relative to where you started from just having read all of the literature.
Yeah, I think that's a great question. What I think the utility is that you're able to parse through many different or hundreds of papers and show visually, for example, that peacekeeping leads to fewer civilian deaths, for example. And that is something that the literature shows partially, but there's a good bit of disagreement on that. Some of our initial analysis, of course, we're not published on this yet, still working on it. The initial analysis suggests that indeed civilian protection is done by peacekeepers, excuse me, and that onset is also less likely with military troops as opposed to like police or observers. Oh, sorry.
Yeah, question for you. So you had talked about PCC, and in economics, that's the field that I'm in. PCC was really common, but I've noticed over the past 6 months with a couple of papers that I've done that now reviewers are really starting to question the usefulness of PCC. Because, I mean, if you're thinking about it, all it's showing you is the impact of the variation. And really, you have to then square that. So if you come up with a PCC that's like 0.05, once you square that, its general interpretability is showing you that there's almost nothing there. And I've noticed that what reviewers are now starting to ask for is to go back to the original findings and to somehow standardize them so you can say what the real effect is rather than just the like hypothesized statistical effect. So I was wondering if you've seen more papers like that, because I know it just literally seems to be the past few months that reviewers have started going back to not liking PCC again. I'm wondering if poli sci is starting to see the same movement as well, or if that's something that you've considered, what potential other methods there might be for integrating some of these studies.
Thank you for bringing that to my attention. I had not necessarily seen that in political science, so good to know that that's maybe where our field could be moving, especially as we look to, send out our work. Um, I had mentioned also the Fisher Z transformation could be potential solution, and that is actually what Godefroy 2022 did in her AJPS paper. So if I had to say what it looks like political science seems to be doing, that seems to be a more flexible way of doing it. A nice advantage to that is, like I said, the PCC is bound by -1 and 1. The Fisher Z transformation is negative infinity to positive infinity. So you get a little more variation there. So that would be my response to the Fisher Z. I need to make a note of this to look of potential other solutions to the PCC. Thank you for saying that.
I have other questions if no one else does.
Go for it.
Okay. Yeah, I was wondering your thoughts on publication bias because you mentioned the FAT test. But there are some others. I mean, like if you're using the traditional fat, then it's just a linear specification. But I mean, some folks think the linear is just fine, whereas others think that actually you should be squaring it to account for nonlinearity. And then there's also a whole variety of other methods out there, like endogenous kink or Andrews and Casey's method. I was just wondering if you had any specific thoughts or any preferences for one of the methods over another, or yeah, just in general, what your thoughts were for correction of that. Because usually in MRA, people just go with basic. They're either going to take linear or they're just going to take square of standard error, and they're not going to worry about the more complex methods for correction. But yeah, I'm just wondering if you have thoughts on that issue, keeping it simple versus going for something more complex.
Yeah, that's another good question. I like what's the word? Sort of for all of the solutions here, start with the simple FAT test, and then there are, as you mentioned, better ones such as the precision effect test. There's a precision effect estimate with standard error or P's. Then you can also mash these together to get like a pet P's overall. Yeah. Again, citing Godefroy, that is exactly what she does. She starts from the very basic, then the trim and fill, I think, is her favorite, and then includes the pet peas in her supplemental information as part of her publication. So I would advocate doing all of these, finding kind of what you're getting out of this, and then showing in the manuscript the one that visually shows the publication bias best while still accounting for, hey, in the SI, we've also done these other like robustness checks for precision, or sorry, for publication bias.
Well, that's great. I'd also be interested in your thoughts on weighting versus unweighting when you come to MRA. Because, yeah, I mean, different people have different opinions on that and what weights you should choose. And then there's also, I mean, it's sort of a divergence because some people do traditional MRA, where you're just essentially using OLS, whereas other folks have moved on. They're using Bayesian model averaging, frequentist model averaging, or weighted average least squares. Weighted average least squares obviously weights it, as does frequentist model averaging, but then Bayesian model averaging does its own thing and just it reweights a whole series of OLS models, but then you can't weight the individual ones. So yeah, I was just wondering your thoughts on weighting versus unweighting and uh, all the different estimators that you use for MRA.
Yeah, another good question. I am a proponent of weighting. The WLS, like you mentioned, is the way that I would recommend you go. That again comes from working with Andy Phillips, the co-author on that paper, and reading these two resources. Um, oh, I forgot the second point that I was going to say. Oh yeah, the Bayesian. I'm not super familiar with Bayesian statistics at all, other than it's not frequentist statistics, and they account for priors. The one person who did that dissertation with the meta-analysis actually did Bayesian. And so we talk a little bit about that in our SI for the paper. I think the big contribution for their work is to account for those priors and kind of illustrating that this is kind of a problem in the literature that this person was talking about by not accounting for the priors. But yeah, my answer to this is I'm an advocate for WLS over not weighted, maybe include non-weighted stuff in an appendix or an SI, again, to try to guard against like reviewers who want to see more work. I think unfortunately that's kind of the issue. Meta-analysis is already a very huge undertaking, and then you're asked to do 9,000 other robustness things to satisfy everybody. But if you have to choose one, I'm for WLS.
Okay, yeah, fair enough. I mean, it is an interesting sort of philosophical discussion because how do you construct the model? How do you deal with uncertainty over what the true specification would look like? And yeah, Bayesians would say, well, you let the data sort it out. Whereas if you don't want to go that route, then you've got to be a little bit more careful picking and choosing. Or yeah, you could sort of start big and then eliminate step by step, see what you get. But yeah, if you do that, then you can use weighting. But if you do Bayesian stuff, you can't. So okay, that's it. That's interesting that you'd go WLS. Yeah, makes sense.
Okay, any final questions?
I mean, I could probably pick your brain for the whole afternoon, but you probably have other things to do today.
I appreciate that.
Although, I mean, because you did mention the conference thing, I don't know. Do you have a lot of conferences in meta-analysis in poli-sci or?
If anything, this would be like you go to PolMeth, political methodology, the big like
Okay.
methods conference, but I don't think that there's anything dedicated specifically to meta-analysis.
Okay, because we do have one in economics, and it does attract people from like occasionally from like medical sciences or poli-sci as well. And it's actually this year, 2025, is going to be in Ottawa, which is not too far away. Like it'd be reasonable. So if you're interested in a conference on meta methodology and seeing what other meta analyses are being done and going on, it'd be something to check out. Let me just see if I can find the link to give to you. I just pop that into the chat. Yes, it's the MayorNet colloquium. So it happens every year, goes on in different places, but yeah, this year is going to be in Ottawa, which is probably not too far to get to from Colorado. So it's an entire conference that's only about meta-analysis.
That's awesome. Thank you so much for the suggestion there.
Yeah. Well,
Huh.
thanks for coming for this talk. It was really interesting.
Thanks for having me. I'm very happy to have been here.
And thank you everyone for joining and have a wonderful weekend. Bye.